Electrochemistry. This chapter deals with the interconversion of chemical energy into electrical energy. For example, battery supply electrical energy stored in the form of chemical energy for the operation of torch, radio, calculators, cars, etc. Or electrolytic processes are carried out in a device known as a cell. An electrolytic or electrochemical cell consists of two conducting metal electrodes in contact with an electrolyte solution, which separates them or placed separately in compartments containing suitable electrolytes. The electrolyte may be an aqueous solution containing mostly the salt of the metal with which the electrode is made of, or it may be an ionically conducting liquid. There are two types of cells known as electrolytic cell and electrochemical cell. Each of them possess different characteristics and are used in different applications. Generally, at the anode, oxidation reaction occurs, and at the cathode, reduction reaction occurs. When the electrodes are connected externally through a wire and the electrons flow through them, the electrical circuit is said to be an open circuit. If the electrodes are not connected externally and the electrons do not flow from one electrode into the other, the electrical circuit is said to be a closed circuit. Daniell cell or galvanic cell is an example of electrochemical cell. The overall reaction taking place in the cell is the redox reaction given on screen. The reduction half reaction occurring at the copper electrode in contact with the aqueous electrolyte containing copper ions receives the electron from the zinc electrode when connected externally to produce metallic copper according to the reaction as given. The Daniell cell is also called as the voltaic cell. However, for a continuous supply of current for a long period, the two half cells, each comprising the metal electrode and its aqueous electrolyte, kept in separate containers and can be connected externally as shown below. When the cell is set up, electrons flow from zinc electrode through the wire to the copper cathode. As a result, zinc dissolves in the anode solution to form zinc ions. The copper ions in the cathode half cell pick up electrons and are converted to copper atoms on the cathode. Cell terminology. Two electrolytes are used. Two electrodes are immersed separately in two electrolytes. A salt bridge connects the circuit. Before taking up the study of the electrochemical cells, we should be familiar with a few common terms. Current is the flow of electrons through a wire or any conductor. Electrode is the material, a metallic rod or bar or a strip which conducts electrons into and out of a solution. Anode is the electrode at which the oxidation occurs. It sends electron into the outer circuit. It has negative charge and it is shown as minus in cell diagrams. Cathode is the electrode at which the electrons are received from the outer circuit. It has a positive charge and it is shown as plus in the cell diagrams. Electrolyte is the salt solution in a cell. Anode compartment is the compartment of the cell in which the oxidation half reaction occurs. It contains the anode. Cathode compartment is the compartment of the cell in which the reduction half reaction occurs. It contains the cathode. What do you know about half cell? each half of an electrochemical cell where oxidation occurs and the half where reduction occurs is called the half cell. Let us see the cell diagram or the representation of a cell. A cell diagram is an abbreviated symbolic depiction of an electrochemical cell. For this purpose, we will consider that a cell consists of two half cells. Each half cell is again made of a metal electrode in contact with metal ion in solution. The IUPAC conventions. In 1953, IUPAC recommended the following conventions for writing cell diagrams. We shall illustrate these with reference to the zinc copper cell. A single vertical line represents a phase boundary between a metal electrode and ion solution, that is the electrolyte. Thus, the two half cells in a voltaic cell are indicated as follows. It may be noted that the metal electrode in anode half cell is on the left, while in the cathode half cell it is on the right of the metal ion. A double vertical line represents the salt bridge, porous partition, or any other means of permitting ion flow while preventing the electrolyte from mixing. Anode half cell is written on the left side and cathode half cell on the right. In the complete cell diagram, the two half cells are separated by a double vertical line, that is the salt bridge in between them. What do you know about electroneutrality? As the process continues, a negative electric charge builds up in the metal. This negative charge, together with the buildup of positive charges in the water, makes it more difficult for additional ions to leave the metal. An electrochemical cell consists of two half cells. With an open circuit, the metal electrode in each half cell transfers its ion into the solution. Thus, an individual electrode develops a potential with respect to the solution. The potential of a single electrode in a half cell is called the single electrode potential. The single electrode potential of a half cell depends upon